Hello everyone, welcome back to our channel. Today we have a special topic. Today we are going to use automated machine learning for the purpose of concrete compressive strength prediction. In this tutorial we are going to use a TPOT library. TPOT means tree based pipeline optimization tool. It is a powerful automated machine learning library. It uses genetic programming in the background to find the best possible machine learning pipeline for your data. TPOT is just one kind of machine learning library. So there are several other machine learning libraries like AutoScaler, MLBox, etc. These kind of automated machine learning libraries automates all the processes involved in the machine learning process, such as data processing, model selection, hyperparameter tuning, etc. Even if you are not expert on machine learning, or even if you know something about machine learning, but sometimes you are not able to achieve the greater accuracy that you need, during such times you can always use these automated machine learning techniques. This is a end-to-end tutorial, so we are going to cover all the topics that we need to know for predicting the concrete compressive strength using this automated machine learning. Topics such as data import and cleaning, train test splitting, model development, training the model, saving the model for future use, and predicting using the saved model on a new data point. These are all the end-to-end steps involved in this machine learning prediction process. Before we dive deep into today's tutorial, I have a small request. Behind every video, we do a lot of hard work to give you the best content. If you like our video, please consider subscribing to our channel. Your subscription means a lot to us and it really motivates us to create more useful tutorials like this. Let's dive into today's tutorial. These are all some of the general libraries that we need for various tasks such as data manipulation and data visualization purposes. And these few functions like train test split, standard scaler, and R2 score, these things we import from sklearn library, and this is our main regressor. This is where our automated machine learning regressor is available. So here we are importing this TPOT regressor from this TPOT library. I have installed this in my machine. That is just a pip install TPOT. You just have to install in your machine, and you can import this TPOT regressor from this TPOT library. And last library is this joblib. Joblib is mainly used for saving the model that we developed in this tutorial, and we use the saved model for our future purpose in this predict file. So this is an end-to-end tutorial. Like we develop the machine learning model, we save it, and we use it on a different data set. This is the data that we are going to use in this tutorial. This data is obtained from UCI machine learning repository. This data has overall 9 data points. So of these 9, the first 8 are input features and the last one is the output feature. So if you are from civil engineering background, you might have known what these variables represent. But if you are not from civil engineering background, then just consider this some data that consists of 8 input features and 1 output feature. Of these 8 input features, 7 are floating point numbers and only 1 is an integer variable. Overall, all input features are numeric data only, no categorical or no string type variables. And the only output feature is a float type. It has decimal points. Our data consists of 1030 data points. So this number represents the total number of data points available in our data set. As I said, we have 9 features, of which 8 are input features and the 1 is output feature. Here I am converting the pandas data frame to a numpy array to make the data set compatible for usage with several libraries. So I am putting the input features into this x variable and I am putting the output feature in this y variable. If I take out the shapes of this x and y, if you look at our x shape is 1030 by 8 and our y shape is 1030 by 1. This is where our main machine learning model building happens. So here we created this function train TPOT regressor. So this function takes 2 arguments. They are x and y. Those are these things. So x represents the input feature and y represents the output feature. When we send these x and y arguments to this function, here we are first initializing this R2 score variable. So we use this variable to save the R2 score at a later point of time within this function. And next I am creating a while loop. So this while loop runs until the R2 score is greater than 0.9. To get a statistically good model, any R2 score greater than 0.85 is reasonable, but I am aiming for a better model to be on safer side. So that's why I am aiming for 0.9 R2 score. And here I am splitting the data set 1030 points into training and testing data sets. Here I am considering only 20% of the data to be test data and the remaining 80% of the data is for training data. So here I have not issued any random state variable. So it means every time you use this function or every time you run this code, this data splitting is different. If you specify the random state variable like this in this also, like this, then every time you use this function or every time you run this code, the data set that you get is always stays the same. It means the splitting will always be the same. But if you remove this one random state, then every time you run this function, you will get a different kind of split. I'm not using this random state variable because machine learning model works best when they are trained on random configurations of the data. But whenever we want to give the machine learning model to someone else and we want to make sure the machine learning model is reproducible, then only we use random state variable to make the machine learning model that we developed works in the same way with the other people also. But here I'm not using that random state variable. So when I share this code with you guys, if you run that code, you may get a different result. Keep that in mind. And once I split the overall data into training and testing datasets, here I am doing scaling operation using this standard scaler. And here I am initiating the TPOT regressor with 5 generations and 20 population size. And these are all some specific commands that are required for this TPOT regressor and the scoring technique, because for the given population size it evaluates the best results for these many generations. So in every time it evaluates the accuracy of the model based on this R2 score only. And once I initiate the model, here I am training the model on the training data set. Here I am using this X-train scaled and here I am specifying this Y-train. Once the model is trained here I am doing a small prediction on this testing data set to see how efficient our model predictions are. So here after predicting this Y-test values, here I'm comparing them against the original y-test values and then evaluating this R2 score using this R2 score function that I got from sklearn library. And once I got the R2 score value, I'm just printing here. So once we are done with this training, so here I'm saving the developed model in this name concrete strength TPOT model and the scalar tpot.pickle. So I'm saving these two, model and scalar, using this joblib library. And once I'm done with my training, I'm just printing this training completed and the R2 score exceeded zero point 0.9, and and also I'm just returning these many variables from this function. Here I have called this function to do the machine learning on this x and y data, and after the training is done, it printed the values of cross validation score and the final R2 score that the model has. Final R2 score is 0.92. It was good and greater than 0.9, and every time we got a score of 0.92 only. So overall this is also an R2 score only because internally we used R2 scoring technique only. And once our predictions are done, I am visualizing the model here. So we have total 8 input features and 1 output feature. So I have plotted all those input features here. So just to get more clearer view, I have just plotted the first two variables in the beginning, that is cement quantity and the blast furnace lag, against the concrete strength. So if you look at these predictions, our machine learning model predicted in a decent way. Our predictions of concrete strength with respect to the cement quantity and blast furnace lag is decent. And if you look at the other input features versus the concrete compressive strength, here this one represents the fly ash versus concrete compressive strength, and this one is water versus concrete compressive strength. This one is super plasticizer, this one is coarse aggregate, this one refers to fine aggregate, and this one is age. So overall our predictions are decent actually. We have no issues in using this machine learning model. Once we are done with this machine learning model, so the last step is to use this machine learning model for making future predictions on a different data set. For that I'm going to load these saved files here in this predict ipynb. So here whenever we issue this command, two files will be saved here. This one and this one. These two files will be saved here. Those two files I'm loading it here using the same joblib library. And here I have created a new input feature. This new input feature is completely new, and all the values that I gave in this input feature are random and do not correspond to any of the data that we used before, neither the training data nor the testing data. It's completely new. And once I have defined this new input feature, I have made some corrections to this predict file. So previously I used this predict file for random forest regression. So I have changed a few variable names from RF to TPOT just to make sure that we are using this file for machine learning model that is generated using this TPOT library. So keep that in mind. So here I have just created a new input feature, and once the new input feature is created, I am doing the scaling operation using this loaded scalar object. And once the input feature is scaled, I am using this loaded TPOT model for making the prediction. And the obtained compressor strength was 66.80. We can remove this. We can neglect all these numbers after the decimal point. So overall our compressor strength is 66 MPa. It was decent. So now you can take this machine learning model and the scalar object, you can put these things in any cloud, and you can make any new predictions on the new data. That's it for this tutorial. If you have any questions or recommendations for future videos, feel free to post them in the comment section. We are happy to help you out. If you like our content, please hit the like button and subscribe to our channel. Happy learning. Thank you.